welcome to Quick Concepts. Today we're going to be talking about triangles. Just a few pieces of information about them, and then we're going to go into similar triangles and how to find sides and angles. So first of all, there's three types of triangles, excuse me. There's isosceles. This means two of the sides are congruent. I'm trying to draw these nicely, but of course I probably can't. Equilateral, that means all sides are congruent, even though that doesn't look like it is. And then of course like a scalene, which looks like this. And then any triangle with a right angle in it. Scalene has, and again the scalene, all the sides are unequal. Then anytime a triangle has a right angle in it, it's called a right triangle. Couple things about when sides are equal, that means the opposite angles are equal. So sides are equal, opposite angles are equal. So here, these would all be equal because all the sides are equal. So you could actually call this an equal angular triangle too. The sum of all angles in a triangle equals 180 degrees. So that allows us, like for an equal angular triangle, to know that all three are going to be 60 degrees, and it allows us, like if you have a 90-degree angle, to be able to find other ones based on that if one of the other angles is given. So that's a little bit of information about triangles. We're going to get into some heavier stuff here as we move along. But really what I want to focus on this quick concept is how to do similar triangles. And what I mean by that is, I'm going to show you this. We have this triangle and we have this triangle. And this is from lesson 4 in your book, number 18. So if you notice, these angles are the same and these angles are the same. When at least two of the three angles in a triangle are the same, then they are similar triangles, because if two are the same, then the third has to be the same. So they say side or angle, angle, it means that angle, angle, angle. So this tells us that the triangles are similar. Well, how does that help us? Well, if I take this one, and I'm just going to recopy it down here, and then I take this one and I rearrange it so all the equal sides correspond, I can do what's called a proportion. I can say, well, 6 is to 4, and you always start the one with both numbers, as x is to 6. And then I can just cross multiply, and I can see that x is 9. And I could do that the same for the y. I could say, well, 6 is to 4 as 10 is to y, and I could cross multiply, divide both sides by 6, and I can see that y is going to be equal to 20 over 3 once I reduce. So that's one way to look at similar triangles. Another one is like in number 19 on that same lesson. Again, this is lesson 4. Let me try to draw that again. So this is exactly how it's written in the book, and I'm going to show you what to do to make them correspond with each other. First of all, understand that this angle and this angle are the same. So I'm going to take this triangle and I'm just going to draw it just as it is in the book, just like this. Now I'm going to take the triangle on this side and I'm going to flip it up and over, so it's now in the same position. Now, what I can do is the exact same thing I did over here. Always start with two of the numbers you already know. I know 3 is to 6, as A is to C. Actually, can't do that one because we do not know C or A. So I'm going to say as 5 is to B. And so I can see B is 10. Now, we're in a situation now where we do not know two of the same sides. So you can't use proportions, but what we can use is what's called the Pythagorean theorem. And you guys pretty much know what this is. And that's what I'm going to do. I'm going to say, well, a squared plus 3 squared is equal to 5 squared. So I can see that A is going to be 4, and then I can do a proportion to find C. I can say, well, 3 is to 6 as 4 is to C, cross multiply, and I can see that C is going to be 8. Okay, and that's how you're going to deal with similar triangles. All right, on the next one, this is essentially the same concept, but it's a triangle within a triangle. A lot of times this really confuses people, but it's really not that bad. So what I want you to notice is that we have one full triangle, which I'm going to write right below it, one full triangle. This is an A, this is B plus C. If we were to put that side together, 2 plus 4 is 6. Then we have this little tiny triangle up front. Now, are these triangles similar? Well, they share a couple angles. They both have right angles. That's 2. They both share that angle. So that's another 2. So we know the third angle corresponds. So we can go ahead and do proportions. So let's try it again. So we're going to say 6 is to 4 as A is to 3, and we're going to cross multiply. And A is going to be 9 halves. We can go ahead and get C by using the Pythagorean theorem here. Taking the square root of both of those, just like that. And then we can do a proportion to get B. We can say, well, 6 is to 4 as B plus 5 is to 5. Cross multiply. Subtract 20 from both sides. Dividing both sides by 4. B is equal to 5 halves. Let's do one more. That's a triangle within a triangle, just so I can show you one more different type. This is still on that same lesson. I've now done 18, 19, 20, and I'm doing 21. I think this is probably the hardest one to find out what corresponds to what. So with 21, what you're dealing with is actually 3 triangles, okay? So you have this one big one, just like this. Now I'm going to turn it up on its side, and I'm going to put it right here. So A is going to be in the bottom, B, and then 8 plus 12 is 20. Then I'm going to do this medium-sized triangle here. Okay, so this one is going to be just like this. Now notice this matches this. Okay, and then this one is going to be the right triangle right there. So the bottom is H, and the back is 12, and this is B. And then the last one I'm going to do is this one. And then this is going to be matching one of this one is here. And that's going to be 8. There's your right triangle. That's H, and that's A. So now you can do a couple different things. We can do a comparison, a geometric mean comparison, and let me show you what I mean by that. I can say, well, for here, for this one, let's look at these two. B is to 12 as 20 is to B. This is what I mean by geometric mean. So when we cross multiply, we get B squared is equal to 240. So I can take the square root of both, and that breaks down to, that's going to break down to something, 240 divided by 16. Yes, so this would be like 16 times 15, and then b would be 4 radical 15. And so that takes care of that. And we could do the same thing for h. We could say, well, for these two, 12 is to h as h is to 8, and that would be h squared is equal to 96. So that one, 6, would be 16 times 6, so h is equal to 4 radical 6. And then lastly, you could do that same thing for the a's if you compare the first and the last. Like if we compared this with this one, we can say, well, 20 is to a, so 20 is to a as a is to 8. And then this would be a is equal to 16 times 10, and so again, it's just 4 radical 10. Okay, and that pretty much covers all the different triangles that we're going to be dealing with here at the beginning of Advanced Math 1.